So what about integrals that involve inverse hyperbolics? Remember, whenever you have a differentiation formula, you get a corresponding integral formula. So you differentiate inverse sinh, you get 1 over root 1 plus x squared. So if you integrate that, you get back to inverse sinh. Similarly, if you integrate the 1 over root x squared minus 1, you get inverse cosh. And 1 over 1 minus x squared, you get inverse hyperbolic tangent. So let's say we want to integrate dx over root 9x squared plus 25. So I look at this and I see it's got a square root in it and it's got a plus sign in the middle. So it's got to match the inverse sinh integral formula. So we want to make this look like 1 plus something squared. So I'm going to do a little bit of algebra here. So we got that dx on top. And then down in the denominator here, I'd like that to be a 1, so it matches the 1 here. So let's factor out a 25. And if you factor 25 out of the 9x squared, you will get 9x squared over 25. So I divided it out here, and then if you multiply there, you get back to the 9x squared. Factor 25 out of there, you get the plus 1. And then we can break the square root apart remember, square root of a times b is square root a times square root b. So this is integral. We got a dx up top. And then in the denominator, root 25 is 5. And then what's left, I'm going to switch places on these and put the 1 out in front. And then I'd like to have something squared in parentheses there. And notice that all these are perfect squares. Square root of 9 is 3. Square root of 25 is 5. And square root of x squared is x. So 3/5 x quantity squared gives you that 9/25 x squared. So then let's see here. We want to use a u substitution to simplify this. If this is our u, then this will be root 1 plus u squared. So let's use u is 3/5 x. Then our du will be 3/5 dx. And we've got 1/5 dx, or dx over 5. So let's multiply by 3 and then divide by 3 on the outside. And so now we've got our 3/5 dx. There's our du. And here's our u. So in the next step, this is going to be 1/3. And then integral on top, we've got our du. And then in the denominator, root 1 plus u squared, which is what we wanted. That is the integral here, and that gives inverse sinh. So this is going to be 1/3 inverse sinh of u, and then plus constant. And now we just have to reverse our substitution. So 1/3 inverse sinh, and 3/5 x, and then plus constant. So whatever your integral is for this section, you're just trying to match one of those three patterns. You might have to do some algebra to get there.